Hi, I want to talk about two equations that have a somewhat dubious distinction as being considered two of Maxwell's equations, even though Maxwell really didn't have that much of a hand in developing them, just kind of got credit for bundling how the story of electricity and magnetism fit together. And the way that we are going to be framing these equations are by taking a look at the idea of flux through a surface and circulation around a surface. So for the first case, the first two of Maxwell's equations are known as Gauss's laws of flux. And the definition of flux is the sum of any vector field moving through a surface. So for the case of electricity and magnetism, we would have an electric field dotted with an area vector, a tiny infinitesimal patch of area with a direction that is normal to the surface that the flux is passing through. For the magnetic flux, it would be the integral of the magnetic field, dotted with that exact same differential area element that's pointed normal to the surface. Now, Gauss's law specifically talks about the case of closed surfaces. And a closed surface is any surface where there is a clear inside. There's an interior volume that is completely closed off, bounded by our surface. And that surface we would call a Gaussian surface. So for electric flux, the electric flux through a closed surface is going to equal the charge inside the surface divided by the permittivity of free space epsilon naught, which is 8.85 times 10 to the negative 12 coulombs squared per Newton meter squared. Now, what this is essentially saying, you can think of flux as being almost a way of counting the number of field lines going through a surface. So if you have a charge inside that surface, then field lines will either start or end at the charge and will be going out or coming in. Because if a line goes out and comes in through that surface, it's just passing through, so its total flux is zero. Now for magnetic fields, Gauss's flux law for magnetic fields says the magnetic flux through a closed surface is equal to zero. And that's the restatement of the classical physics idea that because magnetic field lines form loops around moving charges and a loop can't have a beginning or an end, we can't have magnetic monopoles. We can't have a place where magnetic field lines truly stop. So 50% of Maxwell's equations, Maxwell really didn't have much to do with this. Thanks for watching.